Okay, so we're getting ready to graph a rational function. And so they give you some steps. In the book, there's a pretty long discussion about that with some pictures, though, that might help you to look at. I'm just going to summarize the steps here. Okay. And I'm going to throw in something that's a little bit different than the steps in the book, but it's how I would do it. Okay, step 1, find the y-intercept. You're going to find the y-intercept by evaluating the function at 0. Step 2, factor the numerator and denominator. You want to get it all factored. Okay. Then here's where my little exception comes in. I would simplify here. Note any canceling, because that's going to come up with our removable discontinuities. Okay, so I would go ahead and simplify it there instead of the way the book talks about it. Simplify it and then just make a note to self, hey, I got to check for removable discontinuities. Okay. Step 3, find the x-intercepts. How are you going to do that? You're going to take the numerator, and set it equal to 0. Step 4, find the multiplicities of the x-intercepts. Now you want to do this so that you'll know when you go to graph, does it touch or cross at those points? Okay, so that'll help us know how the graph's going to go. We're going to have a very limited number of ordered pairs that we're actually going to graph, and we'll have to just know about the behavior. Okay, then we're going to find the vertical asymptotes. And how do you do that? You look at the denominator. So set the denominator equal to 0. And then that'll tell you the vertical asymptotes. Now, you also want to note the multiplicity. At those vertical asymptotes. So I'm going to try to explain it here briefly. If you have a vertical asymptote, let's say this is at, 2 here, and it's because you had a factor in your function, something up here, and then you had x minus 2, okay? Then it makes a difference what that exponent is. If the exponent is odd, like a 1 or a 3, then we know that it's going to go either like this or like this at those asymptotes. It's going to go in 2 different directions, okay? If it's 1 or 5 or something like that. But if you had a vertical asymptote, at 2, and then you had like x over x minus 2, but this was even, like a 4 or a 2 or something, then it's going to go in the same direction. It's either going to go this way and this way, or they'll both go down, okay? So that's what we mean by the multiplicity at the vertical asymptote. Either they're going in the same direction, because it had a multiplicity of an even number, or they're going in opposite directions because it had a multiplicity that was an odd number, okay? So we haven't done that before. We kind of threw that in. Okay, so if you're like, what is she talking about? Yeah, that's kind of new. Okay, and then 6, check those removable discontinuities. And I misspelled removable. Okay. There might be some. A lot of times there aren't, but if there is one, then we have to put a hole in the graph and make a note of that. And so it kind of goes back to this star up here. Did we cancel anything? Okay. And then what do we want to find? The horizontal asymptotes. And then finally we'll sketch. Now they don't mention finding more points, but sometimes we find more points if they're convenient just to kind of see what's going on. All right? That's part of the sketching. You might have to find more points. Okay. One more thing on this. You could take a long time graphing these by hand, but we're not going to. We're going to go through the steps. I mean, there's 8 steps already, and then we're going to just do our best to graph it, okay? So we're going to look for these end behaviors and local behaviors and the asymptotes, everything that we're talking about. We're going to look at that and make our best graph that we can. Like I said, you could just spend a long time doing it, but we're going to have other things to do. So keep that in mind.